Last time, I think we got into kind of significant figures for sure, and calculations involving significant figures. Remember that when we do multiplying or dividing, we are looking at sig figs, and it is the least number of significant figures your answer should have. When we add or subtract, there we are looking at decimal places. And again, that should be the least number of decimal places when you do that. If we do sort of a combination of a calculation, you really should sort of keep track of everything along the way and then sort of round it up there at the end to the right significant figures. Keep a few digits. You don't really want to round too much on every step. Otherwise, you may find yourself sort of very far off from the sort of true answer. I think towards the end, we sort of were looking at conversions and sort of dimensional analysis, which is sort of where we are at this point. We can do conversions, which are conversion factors. Like 12 inches is 1 foot or something like that, which would give us 12 inches over 1 foot, or 1 foot over 12 inches. And when we write these sort of conversion factors and we really do the problems, the way we want to set it up is, I think, like how we did a little example there at the end last time. We want to set it up where we can kind of see the units sort of cancel. So if we have a particular unit that we want to get rid of, it's always opposites. So we put that unit on the bottom, we put the other unit up on top, and those guys will cancel each other out as we are basically dividing out the units, and they essentially become one. We do multiply whatever's on top in this case, and we come back and divide by whatever's on the bottom. So if we have 32 feet and want to know how many inches that was, we would set up something like 32 feet, once again, using our conversion factor where feet are in the opposite location, not written as a fraction, but basically the units that are up on top. So to get rid of them, we will go opposite of each other here, and our feet will cancel. We would multiply it out here. 32 times 12 gets us something, 384, it looks like. 384 inches. Now, in terms of significant figures, this is an exact sort of number, as it's a English to English sort of conversion. So we would look at our original number here, which is 32, has two significant figures, which takes us to there. Remember that when we do round, we do not want to change the meaning of the number. So we don't want to call it 38 in that case, as was something else we talked about, I think, rounding. We would want to go to something like 380, which keeps basically the meaning of the number and also has the correct number of significant figures. So that was something I think we talked about last time as well. We don't want to do extreme rounding just to get the proper number of significant figures, but change the meaning of the number. You always want to make sure that you keep the meaning of the number. So you do want to kind of watch that. All right. Any questions on any of that stuff there? I think that's where we were talking about. So I think we also were talking about some prefixes, and again, these are some common prefixes, and we use prefixes to change some of the meanings of some of the metric values that we come across. Like kilometer is 1,000 meters, so kilo is 1,000. And that's a very common sort of conversion. It doesn't really matter the base unit. So for example, here, the base unit is meters. But if you change it to kiloliters and liters, it is the same relationship. 1 kiloliter would be 1,000 liters. If you did kilogram, where gram is the base unit, 1 kilogram would be 1,000 grams. So we can use these sort of conversions for any sort of base unit. Works the same way, bless you, as to how we would use it. So here's a table of some of those prefixes that we sometimes use. And let's talk about how to sort of properly use these. And it's very common where people will look at this column and always want to kind of use them backwards and sort of incorrect when they go to use them. So for example, we'll take a look at centi, for example. So when we go to this table and we see centi is 10 to the minus 2. First off, 10 to the minus 2 basically means 1 times 10 to the minus 2. So scientific notation, that's how you can put it into your calculator if you need to. But what that means, though, when we look at that, all these numbers here, is that's how much there is in the base unit to one of the prefix units. So what I mean by that is if we had 2 units, we have, say, centimeters and meters. The base unit here is meters. The prefix unit here is centimeters. So what the relationship would be is in 1 centimeter, there is 10 to the minus 2 meters. And it's a very common thing. People always do it backwards. They'll go 10 to the minus 2 centimeters is 1 meter. Same thing if we had, say, centigrams. 1 centigram, thank you. 1 centigram would equal 10 to the minus 2 grams. Now, if we had something like nano, which is right here, which is 10 to the minus 9, if we had nano, which is 10 to the minus 9, if I had 1 nanometer, it would be 10 to the minus 9 meters. So again, 1 prefix unit to that is how much of the base unit. So it is a very, very common sort of error that sometimes people will make. They'll always want to do that sort of backwards when they look at those. But this is the proper way to use it. And again, it doesn't really matter the base unit. If we did something like nanograms and grams, there would be 10 to the minus 9 grams and 1 nanogram. So again, it doesn't really matter what the unit is. The prefix works the same. Now, you also will sometimes see larger numbers sometimes used in those conversions, and we get those really by dividing it out. So for example, if we divided 1 times 10 to the minus 2 to both sides, that would give us the one that we also see very commonly, that there is 100 centimeters in 1 meter. So that is how we get to that other conversion. So 100 centimeters and 1 meter is the same as 1 centimeter is 10 to the minus 2 meters. So it's the same relationship. So sometimes people like to use the bigger numbers, and we get those typically by dividing out kind of the exponent number to both sides. And then you kind of get either that bigger number or decimal sort of number that you could use. So either one is fine. Neither one is say right or wrong per se. They both will give you the same answer if you're using it in a calculation. But really important to know how to properly sort of use these exponent sort of factors for your prefixes so that you do not do them backwards. Any questions on that there? All right. So here, if we look at some of these here, 1,000 meters is a kilometer, right? And that's what we just looked at. 1,000 is the kilo sort of prefix. We have 1 times 10 to the minus 6. That is micro if we look at that. So micro, by the way, is abbreviated weirdly in this book and some other books lately, but that I guess is what they use for micrograms. Most people use micrograms with this little symbol here, or micro is that little symbol. But some books nowadays kind of use that for micrograms, but micro sometimes is most often used sort of like that. We probably won't come across it too much here, but 0.1 liter is a deciliter here, as we can see from that chart. And again, we could use any of these sort of equalities as conversion factors. We could say we have 1,000 meters over 1 kilometer, or 1 kilometer over 1,000 meters. So again, we could use it either way. We again won't use obviously both of them in a calculation, but from any type of equality that we have, we can always have 2 conversion factors sort of available to us to do some type of calculation using dimensional analysis. So here are some of our length sort of equalities, some common ones. And again, I would say this one pops up a lot, the 100 centimeters in a meter. Probably not too much of the other ones, but occasionally that guy does pop up along the way. 1 meter is 1,000 millimeters, but really this one we do see and come across a lot in chemistry. Now, volume, some very common sort of volume equalities. I would say out of all these, this is the one that we do come across the most really in chemistry. 1 liter is 1,000 milliliters. So that is 100% a conversion that we use a lot throughout the semester. So 1,000 milliliters over 1 liter as a conversion factor, or 1 liter over 1,000 milliliters. And again, here, if you had something like 325 milliliters and you want to know how many liters that would be, we would use this as a conversion factor. And again, setting it up so we could see the units cancel, we would take our 325 milliliters. Once again, although not written as a fraction, the milliliters are up on top. And that's important because that tells us we should use the conversion factor like this, where milliliters is in the opposite location, so that it cancels. And we will do 1,000 milliliters on the bottom and 1 liter. Once again, we're basically dividing milliliters by milliliters, which, as we talked about, is the same idea as dividing like 2 divided by 2 is equal to 1. So the units cancel out the same way. And this will give us something like 0.325 liters. And again, in terms of significant figures, we would not have to worry about looking at this, as this is considered an exact number. That would then mean that we would fall back to our original number here that had 3 significant figures. So our answer should have 3 significant figures in this particular case. And again, we get this by multiplying what's on top there. So 325 times 1, and come back and divide by 1,000 basically on the bottom there to get to that answer. Any questions on that there? Some other really important relationships in terms of volume are cubic centimeters. One way that we can get cubic centimeters, again, is taking 3 length measurements. And if you measure each of these length measurements, centimeters times centimeters times centimeters, that gives us to our cubic centimeter, which is a volume. Each of these individual guys are length measurements. But if you have like a cube, a solid cube or something like that, you can take a ruler out, measure those 3 sort of directions. You can multiply them together, and that will give you the actual volume of it. In medicine, cc is sometimes used like for syringes and stuff like that, and that's also a cubic centimeter. And the main relationship as well that's important to remember is 1 milliliter is the same as 1 cubic centimeter, and that is the same as 1 cc. So that's all a 1-to-1 relationship between all those things. And they all do represent volumes. So there's a syringe where obviously a lot of times it is cc's that are on there, and maybe milliliters listed here. All right. So in terms of mass, some very common mass equalities that we do come across a lot, I would say definitely 1,000 grams in a kilogram is something that we do see a lot. The milligrams, I'm not sure what all those symbols are there. There's 1,000 milligrams in a gram is another conversion. I'm not really sure what's going on my slide there on the bottom, but that's another one that's a very common one, which is right there. Again, we could use these as conversion factors. So we could say there are 1,000 milligrams over 1 gram, or 1 gram is 1,000 milligrams. And again, we could use these as conversion factors to do any type of problem that we may have. Opposites, again, will cancel out whatever you may be looking for. So opposite locations is what you want to do. So the larger unit in each of these, so let's take a look at these and see. So we have millimeters and centimeters. So a millimeter is smaller than a centimeter. Remember, on a ruler, there's like 10 millimeters in a centimeter, the little dashes on the bottom. A kilogram and a centigram. Kilo is 1,000, centi is like 100. So kilo is larger. Deciliter is larger than microliter, and milligram is larger than microgram in this case. So milligram deciliter, kilogram, and centimeter. Those would all be the larger guys. All right. So let's take a look at each of these. 1,000 meters is 1 kilometer, right? And 0.01 of a meter is our centimeter there. Okay, so those are some of those conversions that we saw on those slides. We're going to skip through some of that. So we've been sort of alluding to writing conversion factors. And that's basically what we have been doing there in those last couple of examples. But really, conversion factors are used, as I mentioned, to help us go from one unit to the next of what we're looking for. And it is basically made from any equality. And again, an equality is anything that is basically two different units that are equal to each other in the sense that they represent the same amount of something, but they are on different scales. So it allows us to kind of go from one place to the next. So when we have any of these equalities, again, we can write conversion factors. So we have 1 meter over 1,000 millimeters, or we could have 1,000 millimeters over 1 meter. And those are the two conversion factors that we could get from that equality that we see there. And that's a metric equality. Here, we could also do it for an English sort of system. 1 pound over 16 ounces, or 16 ounces over 1 pound would be the two conversion factors that we get there. And here we have 2.20 pounds over 1 kilogram, or 1 kilogram over 2.20 pounds. So we have our two different sort of units. We have our metric, and that is metric to metric conversion, which is considered an exact number. So once again, when you're using that in a calculation, you don't have to worry about the significant figures that that conversion factor has. You don't have to really even consider them when you're trying to figure out your answer. This is sort of our English to English conversion, and that also is considered an exact number. So once again, if you're using some type of English to English conversion, you don't have to worry about it in terms of significant figures for your answer. But this is sort of our metric to English. And typically speaking, in most cases, you do need to look at this one. Yes, so you do need to look at this one and look at the significant figures that there are in that type of conversion factor, and take them into account when you're doing your calculation. There is a couple of exceptions that you don't have to worry about, but 1 inch is exactly 2.54 centimeters. So that is an exact conversion and also a metric to English sort of conversion factor. So in that particular case, you don't have to worry about that particular one. There's a couple others, but most metric to English ones, you should look at the significant figures. So what number should you look at in terms of the significant figures? Well, in a lot of cases, there will be probably like a 1. So you wouldn't look at that number. So we would be looking at sort of that number in terms of the significant figures there are in that particular conversion that we may use. Any questions on that there? All right. And as you can see here on labels, they obviously have different units depending on where you're at, sort of our metric and our English sort of conversion and stuff like that. Right. In other countries, they, measure out grams rather than ounces and stuff like that. So their recipes are different. Sometimes you need 500 grams of flour or something like that. Right. So here's some equality significant figures, as I was mentioning. Numbers in any equality between the two metric and two English to English ones. Again, they are considered exact numbers. So they technically have unlimited number of significant figures. And because of that, we really do not worry about them when we're doing calculations. So any of the ones we see here, we could again write two conversion factors from any of these guys, like 1 minute over 60 seconds, or 60 seconds over 1 minute. And if we were going to do some type of calculation where we had 425 seconds, and we want to know how many minutes that was. We would use our conversion factor there on the left, where seconds are in the opposite location. The seconds here will cancel. We're basically going to take 425 and times it by 1 and then divide it by 60. And that will give us on our calculator something like 7.08333, bunch of threes. And the units would be minutes. Now, again, in terms of significant figures, not going to worry about this guy. So once again, here we would worry about our original number here, which I will say probably 9 times out of 10, that's probably where you should be looking in a lot of cases. Not 100% of the time, but more times than not. That's 3, which means we should go here. We're going to look at that 3 that's next to the 8 there, and we will drop it, and we'll end up with something like this, 7.08 minutes as our answer in this particular case. Any questions on that there? Now, when equalities consist of metric to US or English, we should look at the significant figures in there. So all these are sort of crossover sort of conversions going from the metric to the English system. And in this particular case, we would not look at these numbers here, but we would look at these numbers here when we're doing a calculation. So for example, let's just say we wanted to use this equality. We could write our 2 conversion factors, 454 grams over 1 pound. Our 1 pound is 454 grams. So let's just say that we did a calculation and we had, 1,222 grams, and we wanted to know how many pounds that would be. So once again, here we have grams and it's on top. So we need to go opposite of that to get rid of it. So we will take the conversion factor here on the right to do that. We will set it up and do our 454 grams per 1 pound. We'll put that in basically 1,222 times 1 and then divide it by 454. Going to give us an answer here where our grams will cancel of 2.691629929956, which if nothing else, you should know that's way too many numbers. Yes, so you should not give an answer with that many numbers. So in this particular case, because here we are using a English to metric sort of conversion, which is this guy right here, we actually do need to take into account the significant figures, and this guy would be giving us 3 significant figures in this case. Our original number happens to, in this case, give us 4 significant figures, which means our answer actually should end up at 3 significant figures in this case because of that conversion factor. So 2.69 pounds is where you'd want to go. So in the case where you are using something that's an English to metric sort of conversion, you do have to take it into account. I would say in a rare case, you might have to really use it as the number of significant figures, but in a lot of cases, it is that first number, but it may not be in this. For example, like this one that we just did here, it would be that conversion factor that would give us our significant figures for our answer. Question on that there? All right, yeah. Not necessarily the metric number, but a lot of times, as you can see in these conversions here, are equalities. One of the numbers is 1, right? And the other one is like another number that's not 1. So you really would want to look at the one that's not 1. So like we looked at 454. If you were going to use the 946 milliliters in 1 quart, you would look at the 946 and go, okay, it has 3 significant figures. Or even the guy on the bottom there, which is the 39.4, you would look at that number and go, okay, that one has 3 significant figures and stuff like that. So a lot of times when you kind of cross over that sort of English to metric sort of crossover, there will be one of those numbers that will be a 1. And so you don't look at that one, you look at the other one that's not a 1 in that terms of that number. Other questions? Yeah. So we've been sort of doing this, but conversion factors are really important. And then obviously the inch and the centimeter exception to that sort of crossover between metric and English conversions. Conversion factors are really important in terms of showing our work. And again, they're really nothing more than a fraction, as you've been seeing. And we really could just put either part of that equality, either as the numerator, which goes up on top, or the denominator, which goes on the bottom. And again, we write these conversion factors to help us when we do problems with dimensional analysis so we can see the units clearly canceling out. You will never use both conversion factors in a problem because, again, you will undo your calculation basically because they're opposites of each other, right? So if you use them both, you just cancel them out and they didn't do anything. So you only use one. And again, you want to think about opposites basically when you're kind of doing conversions and using these conversion factors. Put the units in opposite locations to cancel them. And if you want to end up with one unit, that one unit usually should end up on top by itself. But you could end up with something where you need two units, like I think how we finished last time. We had one where we had like miles per hour, I think we did, to, I don't know, feet per second or something like that. So you may actually have two units and you need one on top and one on the bottom. So by setting these things up as conversion factors like this and the problems like we do, you could clearly see what unit is in which location, and it just makes it a lot easier. Here are some common equalities in our metric to US crossover, our English to English. So really, if you pull anything from sort of this category here, that's considered an exact number, so you don't have to worry about it in your calculation. If you pull anything really from this sort of category here, that's also going to be considered an exact number, so you don't have to worry about it. If you pull from here, you do have to look at it. So you do need to look at these, except for obviously anyone that says exact next to it, like we have there, which I think in your book might just be that conversion there. So again, if you pull anything from the right column there, and you're using it in a calculation, you do have to take into consideration the significant figures that you see there. Anyone from the first two columns, you're good to go. You could just ignore it and roll on and stuff like that. All right. So here's again some examples, and we've been doing a kind of along here, so we're going to kind of go through this a little bit quicker, I think. But 1 meter is 100 centimeters, and again, from any equality, we can pull out two conversion factors. So those would be the two conversion factors we get: 100 centimeters over 1 meter, and 1 meter over 100 centimeters. Our kilograms and 2.2 pounds. 2.2 pounds over 1 kilogram, and 1 kilogram is 2.2 pounds. Again, here, this one we would not have to worry about. This one we should worry about. And again, we would be looking at really this number in terms of the number of significant figures that we would be using in that calculation. All right, so we want to write some equalities and two conversion factors for each of these here. So let's take a look here. And again, there are a couple ways too that you can sort of find a relationship if you can't find a direct relationship. But on some of these, we should be able to find sort of direct relationships between them. And obviously, we could go look at that table there and find them. And we will see 1 liter is 1,000 milliliters, which gives us 1,000 milliliters over 1 liter, or 1 liter over 1,000 milliliters. And this is our direct conversion. And this is a direct conversion here between milligrams and micrograms. Now, speaking of sort of going from, say, a prefix unit to a prefix unit when you're doing some type of conversion, I would highly recommend maybe always taking it back to sort of the base unit and then go from the base unit to the next prefix unit so that you do get it correct. So if we look at, for example, just roll back here a little bit to this table here. Where's that table? There it is. All right. So let's just say that, you know, we started in, let's say we started in milligrams and we wanted to go, let's just say we had 125 milligrams and we want to go to, say, kilograms or something like that. So sometimes people will try to kind of do it all in one big swoop there. And it's best perhaps not to do that, especially if you're going prefix to prefix, because people always sort of don't move things correctly in terms of numbers and stuff like that. So for example, we can easily find the prefix on a table like this so that we can do the conversion. The base unit here is gram for each of them, right? So we got milligrams and grams. So really the best route when you're kind of going from prefix to a prefix is to take it from the first prefix back to the base unit, and then from the base unit back to the next prefix. So in this particular case, I personally would go from milligrams to grams, and then from grams out to kilograms. And the reason to do that is you can very easily find those conversions on this like table right here. So if we're going to do this, we would need milli, which again, if we flip to the next page here, milli is 10 to the minus 3. So we have milli, which is 10 to the minus 3. So if we look at this table, we got 10 to the minus 3 for milli. We got kilo, which is 10 to the 3. So if we were going to do this conversion, we would want to first start taking milligrams to grams. And by looking at the milli prefix of 10 to the minus 3, again, what that means is, get rid of this here, I think. So I got somewhere right. Get rid of some of my scribble here. There we go. All right, so what that prefix means in this particular case is in one of the prefix, which in this case is 1 milligram, there would be 10 to the minus 3 grams. So once again, that is the proper way to use that. That's our equality. And from that equality, we could have 1 milligram over 10 to the minus 3 grams as a conversion factor, or we could have 10 to the minus 3 grams over 1 milligram. So if we're going to do our first part of the calculation here, we will go (125 milligrams), and we're going to go opposite here. So we want the 1 milligram on the bottom and 10 to the minus 3 grams up on top, and we would use this one. If I stop the calculation right at this point, right, I am in units of grams. So I basically have taken it back to the base unit. And the reason why that's good, because I could very easily just go from the base unit now to kilo, which I could find on this table really easily without having to try to figure out, all right, so milli, I move it like 3 this way and then kilo this way, you know, and try to figure out what happens. So we could use our kilo relationship there, which would be in 1 kilogram, there is 10 to the 3 grams. So again, that will give us 2 conversion factors. That will give us 1 kilogram over 10 to the 3 grams. Or we will have 10 to the 3 grams over 1 kilogram. So if we continue on with our calculation and why it's important to set our calculation up like this, I could clearly see that my units of grams, which I no longer want, is up on top, right? Which means to get rid of it, I need to use grams in the opposite location. So that would tell me that I should use my conversion factor like so here, that will get rid of my grams. So if I continue on with my calculation here, I will have 10 to the 3 grams is 1 kilogram. The units of gram on top and grams on the bottom there will cancel at this point. So mathematically, what we're going to do is multiply the top there, which is 125 times 10 to the minus 3, or basically 1 times 10 to the minus 3, if you need to put it in your calculator that way. We'll hit equals. We'll then divide it by basically 1 times 10 to the 3. And this will give me 0.000125 kilograms here. Now, in terms of significant figures, this is going to be an exact number, so we're not going to worry about it since it's metric to metric. Same deal there, which means we should look at this guy, which has 3 significant figures. And my answer still has 3 significant figures, which is what we're looking at. So I highly recommend it. It's a very common mistake a lot of people make is they try to figure out the kind of direct conversion from like a prefix to a prefix. But it's so much easier just to take it from the first prefix to the base unit, and then take it from the base unit out to the second prefix. Any questions on that there? All right, so then once you try one here, while we have this table here, let's take a look at, let's get rid of all my scribble maybe on this page here. There you go. All right. Why don't we do, we'll do a couple here. Let's say we had 175 nanometers, and I want to know how many centimeters that is. So why don't you give it a try? And again, from the table here, we can see that nano is 10 to the minus 9, and centi is 10 to the minus 2. So figure out your sort of conversion factors, set it up so you can see the units canceling and see what you get. I'll do it as well. Hopefully we end up with the same number. Okay, let's take a look. So again, the route that probably is the best sort of route for everybody would be, again, to take it from nanometers back to the base unit of meters, and from meters out to centimeters. Again, you can find those conversions relatively easy. When we do look at our conversions here, that's going to mean that for nano, whoops, come back. In 1 nanometer, there is 10 to the minus 9 meters, which will give us our two conversion factors of 1 nanometer over 10 to the minus 9 meters, are 10 to the minus 9 meters over 1 nanometer. We also have 1 centimeter would get us 10 to the minus 2 meters. So again, that is the proper way to put those two numbers. Giving us our two conversion factors for that, which is 1 centimeter over 10 to the minus 2 meters, are 10 to the minus 2 meters over our 1 centimeter. So following our sort of pathway here, we're going to take our 175 nanometers. And again, it is basically on the top, the nanometers. So using our first conversion, we do want to use the one here on the left so that it is opposite and everything cancels. That will give us 1 nanometer is 10 to the minus 9 meters. If I stop my calculation right at that point, I have now taken it back to meters. You could get an answer at this point if you wanted to, but since we have to go one more step, I'm just going to kind of continue on the calculation. At this point, we have meters, and again, we can see meters are up on top. So to get rid of it, we want meters on the bottom. So that means that we will have to use this conversion here to do it, and that puts the meters on the bottom. So our 10 to the minus 2 meters is 1 centimeter. So our meters cancel. That leaves centimeters up on top, which is the only unit left, which is what we're looking for. So again, here we're going to multiply everything across the top, which is 175 times 10 to the minus 9, or basically 1 times 10 to the minus 9. You get it equals. You then want to divide it by basically 1 times 10 to the minus 2 on the bottom. And that will get us 0.1234175 centimeters. Or obviously you could do a little scientific notation here, which would be 1, 2, 3, 4, 5 centimeters in this case. Yeah. Once again, both of these are exact numbers, so we don't have to worry about it. So 3 significant figures there, 3 significant figures on our answer. Any question on that conversion? Yeah. Again, on your calculator, depending on the type of calculator that you have, you may need to type it in scientific notation as 1 times 10 to the minus 2 or 1 times 10 to the minus 9. Any questions? Using obviously your exponent button like we talked about previously. Yeah. Any questions on that type of conversion? Yeah. So again, that's a very common thing as people sort of mess up on. They just want to kind of move the decimal point. I know there's a song or something that tells you how many decimal points to move and stuff like that. I have no idea what the song is, but probably the calculation is a much better way to doing it. All right. I don't talk about that before I got too far there. All right, here. All right, so we were here. So as we were talking about here, when we have an equality, we may have an equality that's actually given to you in the actual problem. So for example, in this here, we have a car that travels at 85 kilometers per hour. That basically is a conversion factor that has obviously the 2 units. Something per something is basically a fraction. That basically means you could go 85 kilometers in 1 hour, or in 1 hour you could travel 85 kilometers. In this case, because this is not a true every situation conversion factor, it's just specific for a problem, you do need to look at the significant figures here. So here we would look at the 85 and go, it has 2 significant figures. If we were doing some type of calculation with this, again, because obviously it's specific for this problem, and people don't always travel, no matter what the situation, 85 kilometers per hour, right? So it's not an exact conversion all the time. It's something that was given to the problem. For example, here, another one that you could find maybe perhaps in a problem is 500 milligrams of a tablet contains vitamin C, or 500 milligrams of vitamin C is contained in a tablet. It's probably a better way of saying that. So our equality here would be 1 tablet has 500 milligrams of vitamin C. That would give us 500 milligrams over 1 tablet as a conversion factor, or the opposite, 1 tablet is 500 milligrams. Again, in this case, not all tablets are 500 milligrams, right? So that's not always the exact conversion all the time. This is specific for a problem. So here again, we would need to look at this if we were doing some type of calculation. And in this case, we would look at the 500 here. And the 500 written like that has how many significant figures? Has only 1 significant figure. So that would be really the one that would be limiting our answer in this particular case if we had to use this in a calculation. So in addition to sort of table sort of equalities and conversion factors that you pull out, a lot of problems will have sort of conversion factors written in the actual problem. And in most of those cases, you should look at the significant figures of those conversion factors when you're doing some type of calculation. Now, sometimes we are given numbers as percentages in problems or something like that. And a lot of times we do want to kind of convert it into a usable sort of conversion factor. And the easiest way to convert a percentage into sort of a usable number is to assume that you have 100 of it, right? So if you got like 80% on your exam, that means you probably got 80 points out of 100, right? Just keeps the number the same. You can really assume as much as you want, but it will change the number. So 100 keeps the number the same. So if we had somebody that had 18% body fat by mass, that means that he has about 18 kilograms of body fat per 100 kilograms of body mass, which would give us our conversion factors here of 18 over basically 100, or 100 kilograms of body mass over 18 kilograms. 18 kilograms is measured and has 2 significant figures, and the 100 kilograms is exact. So here we would look at the 18 for our significant figures here, because really in the problem, that is really the number that was given to us. We added the 100, right, to kind of convert it into a percentage and a conversion factor. So we would want to look at the 18 there in terms of it, which would have 2 significant figures if we were to use this in a calculation. Also dosage as well. So Keflex antibiotic is available in 250 milligrams capsules. So 1 capsule would have 250 milligrams. And again, that will give us our 2 conversion factors. And once again, here we would be looking at the 250 as to having 2 significant figures if we were using that in a calculation. So in addition to looking at sort of conversion factors that cross over from metric to English, any type of conversion factor is sort of derived from the problem. Probably you should look at it in terms of the significant figures and the answer that you get. Any questions on that there? So So if we look at some of these conversion factors here, we have 10 decimeters is 1 meter, and 1 meter is 10 decimeters. Here again, we have something that contains 18% gold. So we could have 18 grams of gold and 100 grams of jewelry. And 1 gallon of gas is $2.40. You can see when this book was made, right? I don't even think you get any gas for that cheap. So 1 gallon would give us 240. It probably was expensive when they wrote it. 1 gallon is $2.40, or $2.40 will get you 1 gallon. Yes, please. Where do I go fill up? But in terms of sort of looking at significant figures, obviously when we use this, here, this is really metric to metric, right? So we wouldn't have to really worry about it. This again is a percentage that's really derived probably from the problem, so we should look at it. And once again, here we would be looking at the 18 number there in terms of the significant figures. And here, this also obviously is not always the case, so we would look at that, and we would be looking at that in terms of significant figures here. So again, sometimes, a lot of times you can almost ignore a lot of conversion factors that you look at, but there are certain situations where you really shouldn't ignore them and you should look at them in terms of the significant figures in your answer that you get. Any questions on those differences? All right, so let's talk about really problem solving, which is sort of what we've been doing in a lot of these examples. Problem solving, and it's usually sometimes also called dimensional analysis. And it is a way that we set up the problem, as we've been doing in some of these examples, where we could use our conversion factors. We could see what units cancel, which ones do not, and what we're left with. So there are several steps that you can follow when you do sort of a dimensional analysis problem that can be helpful. You want to identify what's given to you in the problem. So a lot of times if you can identify what's given to you in the problem, and you know what you want to find, that's also a good thing to sort of identify. You want to think about a logical pathway that's going to get you from the unit you're starting with to like really the unit you want to end up with. So there is a pathway. And with conversions, there could be multiple pathways depending on sort of what conversion factors you choose. Somebody could kind of take a pathway that goes this way, and some could go like this way. Some may be a little bit more straightforward of an answer to the end, and some may take a couple extra steps to get there. But if you choose all correct conversion factors and not ones that you make up yourself, no matter sort of which pathway you go, you should end up with really the same answer at the end. So don't be surprised in some cases, there are sort of different ways you can kind of get to the end, especially with conversions that you do. Once you do that, you want to think about the equalities that you could use and the conversion factors. And then really the most important thing is to set it up so that you can see the units canceling and obviously see what you are left with. So if a person weighs 178 pounds, what is the body mass in kilograms? So here we want to think about, for example, we are starting in pounds, but we want to get to kilograms. So there are different pathways that you could choose. So maybe you're looking at a table and going, all right, well, 1 pound is, as we saw, 454 grams, right? So that gets me from pounds to grams, which is not bad. Then I need to go from grams to kilograms. And I look on my table, and kilo, right, is 10 to the 3, which tells me that in 1 kilogram, there is 10 to the 3 grams, or 1,000 grams, basically, right? So that is a pretty good pathway. I could go from pounds to grams, and then grams out to kilograms, and then I would be done here. So now that I have sort of the idea of how I want to get there, we want to think about what's available to us to help us get there, which is our conversion factors. So for each of these equalities, we want to write our 2 conversion factors. So for the first one, we could have 1 pound over 454 grams, or 454 grams over 1 pound. For our second one there, we could have 1 kilogram over 10 to the 3 grams, are 10 to the 3 grams over 1 kilogram. So these are our 4 sort of conversion factors that we could kind of draw upon as we go through this problem, Once again, you're not going to use them all, otherwise you pretty much undone your entire calculation. But we're going to use the ones that will help us get there. So where we want to start with is obviously what was given to us, which is 178 pounds. So here we'll go with 178 pounds. Once again, it is not written as a fraction, but the pounds are assumed to be up on top. So I know, again, opposites will cancel. So when looking at my pounds to grams conversion, I will want to use the one here on the right, as that puts the pounds in the opposite location so that it can cancel out. So that is where we're going to start our calculation here. We're going to put the 1 pound on the bottom and the 454 grams up on top. If I stop my calculation right at this point, the pound and the pound will divide out basically and cancel each other out. That means the only unit that I have left right at this point is grams. Yeah. And grams are currently sitting in where? Top or bottom? The top. And again, this is why it's important to set it up like this so there is no doubt what you need to do next. We need to get rid of the grams. So again, just opposite locations. So looking at our two options for our second conversion factor, we would actually need to use the one here on the left-hand side, as that has the grams in the opposite location. So we would do that. And we will go with basically 1,000 grams on the bottom is 1 kilogram. Once again, here, the grams on top and the grams on the bottom are going to cancel each other out. That's going to leave me my one and only unit left, which is on top, which is typically what you want. If you have only one unit, you're going to end up with that unit should always end up on top by itself. Yeah. So that's usually where it should be. Now, mathematically, what we're going to do is we're going to take anything that we have up on top and we are going to just multiply. So anything that we have up on top, we're going to multiply. When we get to the end, we're going to hit the equal sign. Then we're going to come back basically and divide by what's on the bottom, but really you don't need to divide the first one since it's 1, but you can if you like. And you want to hit equals and then divide one more time there and hit equals. Yeah. And if we do that, we got a 178 times a 454, hit equals, divided by basically 1 times 10 to the 3, or that's 1,000, which will give us, let me get my pen here, something like 80.812, and the units here are kilograms in this case. Any questions on that there? Now, let's talk significant figures here. Do I need to worry about the significant figures in this conversion factor? I do not, because it is metric to metric. Should I worry about the significant figures here? I should. This is a English to metric conversion, and 454 is not an exact number. The real exact number is 453.6. That one is actually the exact number, but 454 is sort of a rounded version of that number. So that would technically have 3 significant figures in our calculation, right? We also need to worry about our original number, right, which has 3 significant figures. That means our answer should end up with 3 significant figures. In this type of calculation where you're just doing conversion and conversion factors, you're doing nothing really more than multiplying and dividing all the time, which means you should just look at significant figures when you're doing this type of setup. 3 sig figs would take us to here, which would get us something like 80.8 kilograms. Yeah. Questions on that? I don't know who got first. We'll go here first. I got it. Yeah. Yeah. Was the range of error like he gave me an answer like 80.9?
Yeah, because if I use the 1 kilogram being 2.2 pounds, 2.20 pounds, I get 80.
Yeah, so again, you should get fairly close to this number, really close, no matter which way you go. And you might get a slightly different one if you sort of choose that, again, alternative pathway. So I think you would be okay in that case. As long as I could see that you chose a correct sort of conversion factor along the way, and you didn't give me at the end like 80.9362 or something like that, it would be okay. Was that sort of the same question or no? Yeah. Okay.
178 times
Yeah.
And I divide it by 10 to the third.
Yeah, so that's really 1 times 10 to the 3. So you want to hit, if you're 1 exponent button 3.
So why?
Exponent button like we were doing when we did scientific notation, and then 3, and then you should be good.
Okay.
Yeah. So you don't want to do like a times 10 and a caret or anything like that, because that will throw it off.
Sorry, that's fair.
Yeah. So you'd want to put something like, for example, you would basically go 178. You would hit your multiplication button. You would hit 454. You'd hit equals. Then you would hit your divide button, and really you probably do 1 exponent button and 3, and then hit equals, and then you should probably get that, depending on your calculator. But most of those that would work. Yeah. So those would probably be provided for you. You just need to know how to use them correctly. How's that? Some conversions may not be provided that you should maybe know. And if you look at the review sheet for like the exam and stuff, there may be some conversions on there that says, hey, you should know those. So those might not be provided for you. Again, you won't be given any type of formulas, and that includes, like temperature conversions and those type of things. But something like, there's 5,280 feet in a mile would probably be given to you. Just need to make sure you use it right. And kilo, centine, those things would probably be given to you like we've been doing here, like 10 to the 3 or 10 to the minus 2. So you need to make sure you know how to do it correctly. Okay, let us continue on. So we did this problem, as I was mentioning before, when you're doing conversion problems, again, there can be multiple pathways. As we'll see here, the book chose a different pathway, kind of similar, I think, to what you did there with the 2.2. But this also could obviously get you there from pounds to kilograms, and sort of a more direct sort of conversion here. And here you can see, even though going our way or this way, we really do end up with really the same answer. And again, that would not be a big difference there, the 80.9 versus the 80.8 that we got. But here they did take into account as well the significant figures of that conversion that they use, which is again a metric to English conversion. And again, you can see you essentially get pretty much the same answer regardless of which way you go. So there definitely can be multiple routes to the correct answer, depending on which pathway you choose. And so you just choose whichever one seems logical to you, right? It doesn't necessarily have to be one way or the other, as long, again, as they are legitimate conversions and not just made up conversions there in your head. So for example, here, if we had 2.44 meters and we want to know how many centimeters, we do know, for example, our centi is 10 to the minus 2, which means in 1 centimeter, there is 10 to the minus 2 meters. By the way, as we also saw, that's the same root as 100 centimeters is 1 meter. So you really could use either one, whichever one you like. They both should really give you the same answer. In this case, we have pretty much a direct conversion from meters to centimeters. We could use our 100 centimeters over 1 meter, or our 1 meter over 100 centimeters. And again, you could also use conversion factors for that if you would like instead. They both, again, should give you the same answer at the end. We'll do our 2.44 meters. Once again, meters are up on top. So going opposite here, we want to use our conversion factor that has it in the opposite location, which would be 100 centimeters is 1 meter. Our meters will cancel. We'll take our 2.44 times 100 gets us 244 centimeters in this case. Once again, here, that's going to be an exact number, which means we do not have to worry about it. So we're going to default back here to our original number, which had 3 significant figures, and we get 3 significant figures. Once again, if you chose to do this conversion here, that would give you 1 centimeter over our 10 to the minus 2 meters, or our 10 to the minus 2 meters over 1 centimeter. And again, just to show you here, it should come out the same. We'll use our conversion, the guy on the left there, 10 to the minus 2 meters over 1 centimeter. Meters will cancel. In this case, we would be taking 2.44 divided by basically 1 times 10 to the minus 2. Again, you want to make sure you use your exponent button and you'll end up with your 244 centimeters. So, if you want to punch this in, whenever you see like the 10 to the minus 2 or 10 to the 3 in that sort of prefix, those are basically 1 times 10 and 1 times 10 to the 3, for example. And again, this just brings it back to scientific notation, which means you should be using your exponent button when you kind of punch those into your calculator. Does it matter which one you did? The top? It doesn't. Yeah. So again, like I said, if this is the one you like a little better because it's a more of a whole number, 100 versus the 10 to minus 2, it comes out the exact same way if you use, the 10 to the minus 2. So you could do it either way. And in terms of credit, what you do need to show is pretty much this. Yeah, that setup of it with the units canceling out the proper conversion factors, proper significant figures. If it helps you to write the equalities and pathway and all the conversion factors, you could do that. You don't necessarily have to do that for full credit, but for full credit, you do need to show kind of what's in the box, the setup with the conversion factors, using dimensional analysis so everything sort of cancels out correctly. And then obviously your answer with the proper number of significant figures at the end. Any questions on that? Yeah. Right now, none. So hopefully by Monday, some more than that. So probably 3 or 4, to be honest with you, and probably problem-based type questions. I don't know. I haven't written yet. So it'll be a surprise to all of us when we show up on Monday. It'll be good. Hopefully I'll remember to bring it. That would be an even better thing to do, I suppose. Now, obviously, we've used conversion factors to go multiple steps. And sometimes you may have to use multiple conversion factors in a row. And you can do it like we've been doing on some of the examples we've been looking at, where you just kind of go from one to the next to the next. You could also, if you wanted to, really do it sort of step by step. So if you did like the first conversion, get an answer, you then can take that answer, do the next conversion, do an answer, rather than sticking it all together in sort of one big calculation. You could do it either way. What I would recommend is, as we talked about, I think previously as well, if you are going to maybe do it kind of step by step and you have multiple sort of conversions you need to do, try not to round to the end. Yeah. So keep a good amount of digits until the very end and then round it up at the very end. Again, so you don't really move yourself too far away from the correct answer. So for example, here, if you're prescribed a doses of 0.15 milligrams, and you have 50 microgram tablets in stock, how many tablets do you need? So once again here, we do need to make sure that we get everybody sort of in the same units. So we have different units. We have milligrams here and we have micrograms. So we can't use them together. Our conversion factor is really this guy here. As you see, 1 tablet is 50 micrograms, which would give us 1 tablet over 50. Okay, I'll try to remember to use that. Micrograms are 50 micrograms over 1 tablet. And that's the same as micrograms there. So if we try to use our milligrams with that, it's not going to cancel out correctly. So we do have to do a conversion, and you can really do conversion either way. You could either convert that kind of conversion factor into milligrams per tablet, or you could probably easier maybe convert the milligrams into micrograms, and then you could just use it as a conversion factor at that point. So sometimes you may have to kind of convert a couple of things together to get it to work. So for example, here, we'll take a look at it here. We would have there 0.15 milligrams. And we have 50 micrograms, right? I never write it like that. I don't even remember how they write it. MCG, there we go, micrograms per 1 tablet, I think is what we got going on there. All right, there we go. Oops. And they do have a decimal right there. Okay, so we obviously have our 2 sort of conversion factors that we could get, which is again our 50 micrograms per 1 tablet our one tablet is 50 micrograms. So our pathway that would make sense to us is, again, we would probably want to go from milligrams to grams and from grams to micrograms there, as we could go again back to the base unit to do that. So our micro is 10 to the -6, I believe. So if we look at micro is 10 to the -6, our milli is 10 to the -3 in this particular case. So we can use this to do our conversions. So once again, this would mean that in 1 milligram, there is 10 to the -3 grams. And if we do that as our conversion here first, 150 micrograms, 1 milligrams to 10 to the -3 grams. Our milligrams will cancel. We have now taken it back to the base unit, which we can easily find. And again, once again, we can go and use our conversion here for micro, which is our 10 to the -6. And that means in one, I'll use their conversion there. 1 microgram is 10 to the -6 grams. It kind of hurts to try to use it like that. All right, so we will want to put grams on the bottom. So once again, this is going to give us two conversion factors of 1 micrograms over 10 to the -6 grams, are 10 to the -6 grams over 1 microgram. So here we want grams to cancel. So we're going to use it in this fashion here. So it's opposite. As we could clearly see, our grams are up here on top. So that's going to give us 10 to the -6 grams is 1 microgram. The grams here will then cancel. We'll be left with micrograms. So we're going to do 0.150 times basically 1 times 10 to the -3. We're going to hit equals. We're going to divide it by basically 1 times 10 to the -6. Again, make sure you use your exponent button. And I believe I'm going to end up with 150 micrograms in this case. Yeah. Any questions on that conversion there? So the purpose of why we're converting this number into that is now that's going to work fine with our conversion factor that was given to us in the problem, since it's in micrograms per tablet. So we could actually finish this up by still doing our opposites here, right? So micrograms is up on top. So we need it on the bottom. So we will use this conversion factor here to do that. That's going to give us 50 micrograms per tablet. Micrograms will cancel. We're going to take 150 divided by 50. That's going to be 3 tablets in this case. Yeah. Any questions on that there? Now, if we wanted to really sort of significant figure it up, it really should be perhaps 3.0 tablets, as that's an exact conversion. That's an exact conversion. This we do need to look at that has actually 2 significant figures. And this guy here has 3 significant figures, which means really we should end up with 2 significant figures in this answer here, which would be really 3.0 tablets, although it is a tablet. So I don't know if you would break it in half if you got 3.2 or something like that, but you'd probably give the guy 3 tablets. Yeah.
So will we be marked wrong with 3 tablets?
So significant figure wise, it really should be 3.0 tablets. I don't know if I would mark you wrong, but since we are talking about sig figs, technically speaking, that's why they really kind of put the decimal there, probably on the 50 as well. Yeah. So any questions on that? Now, if they didn't have the decimal on the 50, it would be 1 significant figure there, then 3 would be perfectly fine in terms of that. All right. So here you can see they did leave it as 3 tablets, but I don't know. We'll go with 3.0. All right. We're going to skip this one, I think. We're going to go to this one. If you pace on the treadmill is 65 meters per minute, how many minutes will it take you to walk a distance of 7.5 kilometers? So why don't you give it a try and see what you end up with? I will tell you kilo is 10 to the 3, right? So why don't you give it a try, see what you come up with here. We're looking for how many minutes it'll take us to walk that far. Okay, let's take a look. So here we want to know how much time it's going to take us. This is really a rate and a sort of built-in conversion factor that we could use. We're basically moving 65 meters per minute, or we could use it in the opposite way. In a minute, we will go 65 meters in that case. We are walking a distance of 7.5 kilometers. And really, this rate is what's going to turn us from sort of distance into time. But we cannot use them together the way they are because obviously one's in meters and one's in kilometers. So we do need to do that conversion as well. So I'm going to go from kilometers to meters using my conversion here. And that means that in 1 kilometer, there would be 10 to the 3 meters, which would give me my two conversion factors that I need, which is 1 kilometer over 10 to the 3 meters, or 10 to the 3 meters over 1 kilometer. And again, that is 1 times 10 to the 3, or basically 1,000 is what you got going on with that on top. We will take our 7.5 kilometers. Once again, kilometers are up on top, so we want to get rid of them. So we will use the conversion factor where it's opposite. That will give us 1 kilometer is 10 to the 3 meters. Our kilometers will cancel. And at this point here, we're basically taking 7.5 times 1 times 10 to the 3, basically. Again, using your exponent button, going to give us 7,500 meters. Now that we have this in meters, we can definitely use the built-in conversion factor in the problem. And we, again, still want to go opposite. So meters on the bottom there, minutes on top, which is good because we're looking for the time it's going to take us to do that. So we want to end up with the minutes up on top. So we'll do our opposites here. 65 meters is a minute. The meters cancel, so we're going to divide that by 65, hit equals. Gonna hit us with a 115.38 minutes. Now looking at sig figs here, we're not gonna worry about this. This guy's got 2 sig figs. We should look at this one, which also has 2, which means we should end probably right about there. And that's gonna be $1.20 minutes, right? No decimal, because if I put a decimal, it then has 3 significant figures, right? So 120, no decimal point in that case. Question on that there? Yeah.
So when it comes to the meter,
Yeah.
the tens, that's the meter, like that's what you use each time. You know what I'm saying? It's like 1 kilometer is equal to 10 to the power of 3 millimeters.
Uh-huh.
So then it's the same for like other ones would say like that's like
Yeah, for like centi, for example, it says
Yeah.
10 to the -2.
okay, that's right.
It would mean, so when you see that like 10 to the 3, or like, for example, centi, I think we looked at was 10 to the -2. When you look at these numbers, once again, when it says 10 to the 3, really what that means is 1 times 10 to the 3, basically in scientific notation. So that, again, that's how you would punch it into your calculator. But what those numbers represent is how much there is in the base unit to one of the prefix units. So for example, here, the base unit is meters. So there would be 10 to the 3 meters in the base unit to one of the prefix units, which would be kilometers in this case. And that would be the same thing if we had something like in 1 centimeter, there would be 10 to the -2 meters, which is the base unit in this case. And it doesn't really matter the base unit if you had 1 centigram. it would be 10 to the minus 2 grams, as grams would be your base unit in that case. So that's always how those goes. And it's very common. People will do something like there's 10 to the 3 kilometers in 1 meter, and they'll always kind of do it backwards and stuff like that. So it's a very common error that a lot of people make. Other questions on that? All right, so hopefully they agree. That's good. They do agree. All right, let's try another one here. Let's say you go to local AM, PM, get yourself a beverage on the way in. You drink 32 fluid ounces of Diet Coke from the Thirst Oasis. Crushed ice, of course. How many gallons of Diet Coke did you drink? Here's some equalities that might be helpful, some conversion factors. Set it up with dimensional analysis, see what you end up with. And so one pathway is fluid ounces to quarts, and then our quarts to our gallons. Here's all the possible 4 conversion factors that you can use from those equalities. Once again, you're not going to use them all. We will start with our 32 fluid ounces here. Once again, our fluid ounces are up on top, so to get rid of it, we want to go opposite. So we'll use our conversion factor here on the left that will do that for us. That will give us 1 quart up on top and 32 fluid ounces on the bottom. Again, if we stop the calculation right at this point, we are in units of quarts, which is close to what we want, but we do want gallons. So again, at this point, if you want to get an answer, you can, or you could again just kind of continue on with the calculation, which is what I'm going to do. Again, setting it up like this, dimensional analysis, there's no doubt my quarts are up on top, so that makes my decision very easy. I need the quarts in the opposite location, so I'm going to go and grab the proper conversion factor that will do that for me, and that's going to put that on the bottom. We got our 4 quarts and our 1 gallon up on top. Quarts will cancel. Once again, here we're going to multiply across the top, so it's going to be like 32 basically times 1. We're going to divide by the bottom, which would be 32, hit equals, divide by the next number 4 and hit equals. And you should get something like 0.25 gallons at this point. You do not get 1/4 because it makes me feel like you're too lazy to divide it out. Yeah, so don't leave an answer in a fraction, because I've had people give me answers like, well, it's like 455 miles over 360 hours. Looks good. Looks like an X. Yeah, so don't leave it like that. Don't leave it a fraction. Divide it out. Take it to the right sig figs. Sig fig wise, in this case, pretty much coming back to that number there that has 2 significant figures. Everything else is pretty much an exact conversion. So you don't have to worry about those numbers, which gives us 0.25 gallons. Any questions on that one there? All right. Let's try this one here. During surgery, a patient receives 5 pints of plasma. How many milliliters of plasma were given? Quarts, 2 pints there. Here are some conversion factors that might be helpful. So set it up with dimensional analysis and the units canceling and all that good stuff there. Okay, so looking at this one, you can kind of tell from my equalities and conversion factors, my pathway I'm going with is pints to quarts, and then quarts over to milliliters in this particular case. We will start with our 5 pints, which is what was given to us. Once again, we could think about it that we really just want to get rid of that unit. So we will use a conversion factor that's in the opposite location that allows us to do that, which is that guy right there. We will do 1 quart is 2 pints. Again, if we stop the calculation right at this point, we are in units of quarts, and we can see quarts are up on top, and we still need to get rid of it. So we're going to go to our other conversion where we will put quarts in the opposite location, which means we should use the one on the right there. And if we do that there, 1 quart, 946 milliliters, quarts will cancel. Once again, it does leave us the unit that we're looking for by itself up on top, which is typically what, again, you want when you're solving for one unit. So here we're going to take a little 5 times a 946. We're going to hit equals. We're going to divide it by 2 and hit equals, and 2365, I think it says in my dark calculator here, 2365 milliliters. Now, significant figure wise, not going to worry too much about this guy. This guy's got 2 significant figures. Should I really worry about this one? The answer is yes. And in this case, it would have 3, which means my smallest is still my original guy, which is 2. And we should end up here. That makes this 2400, not 24. Yes, so that would be 2400. 24 is different than 20. Did I? Yeah.
No, I
Yeah.
have a question.
Yeah.
Write it as 2.4 times 10 to the minus 3 amount.
You can write it 2.4 times 10 to the positive 3. Yeah. But that would be perfectly fine in scientific notation. Yeah. So you absolutely could do 2.4 times 10 to the 3 milliliters. That will give you your 2 significant figures. If you didn't write it like that, then you could write it like this. Again, I didn't put any decimal points, so none of those zeros would be significant in that case. Yeah.
So we like multiply across and then divide.
I'm sorry, say it one more time.
So like you know how multiply 5.0 times 3.6,
Yeah.
and then you divide it by 2, like divide it by 1.
Yeah.
Could we multiply like the bottom numbers and not divide it?
You can. So I would caution you to be careful. So a lot of people, in my experience, will set it up correctly, but there's like a big disconnect between how to properly punch it into the calculator and doing it correctly. So my recommendation always is on these type of problems where you have it set up like this, is just to be safe, is you can multiply as many numbers as you want up here on top. But when you get to the end, you should hit equals. And then to be safe, you should come back and divide by whatever numbers you have here individually and hit equals. So for example, the previous problem, we actually had 2 numbers on the bottom, right? So the best thing to do is like, so let's go look at that one real quick, just to, if you really want to never have like a sort of calculator error, if you will, you multiply across the top, and you really don't have to multiply the ones, you can leave them out if you don't really want to. But when you get to done at the top, you should hit equals. And then you should come back, for example, here and divide by 32 and hit equals. And then divide by 4 and hit equals. And you'll always get the right answer. Sometimes when people try to put like these guys together at once in their calculators, you don't punch it in correctly with, say, parentheses or something like that, you'll get the wrong answer. And I've even seen people do what I think you're asking, which is kind of do the top part of the calculation separate from the bottom part of the calculation, and then bring those numbers together. It almost never always fails that somebody always kind of brings them together incorrectly at that point. So if you just kind of do it all in one sort of calculation on your calculator and just punch it in, punch it in, punch it in, hit equals, divide, hit equals, divide, hit equals, you'll always probably get the right answer, provided you punch in the correct numbers, I guess, and those type of things. But that's usually really the best way to kind of do it. But the truthful answer to your question is, if you do it correctly, you can multiply everything on top and get a number. You can multiply everything on the bottom, get a number, and then divide them. And again, as long as you do it correctly, you should get the right answer. But I've seen many, many people sort of make mistakes when they try to do it that way. Yeah. Other questions? And the most common mistake is when people try to punch in that bottom part when there's multiple numbers like all together. They try to just punch everything into their calculator and never hit the equal sign. So you can never really go wrong a lot of times, kind of hitting the equal sign more times than you think you need to after each of the individual steps. Because really what that does tells your calculator is, oh yeah, I want to divide by this number first, and then I want to divide by this number next. And it kind of tells your calculator, like, no problem what you want to do. All right, so why don't you give this one a go here. You are stranded 125 miles away from home with no money, and you decide it's only 120 outside. Let's take a walk. And you walk at an average of 55 feet per minute. How many days is it going to take you to get home? provided you don't stop, eat, or sleep. All right, so see what you come up with. There's some conversions, equalities. Okay, let's take a look since we're getting to the end here. So again, we really want to go 125 miles. This is really our rate, right? Which is how fast we're moving, which is sort of a built-in, again, conversion factor that we could use. We could also use it in the opposite direction if we needed to, minutes on top and 55 feet there on the bottom. We do have a problem. Our distance is in miles and the sort of rate there is in feet. So again, we do need to do some type of conversion to get them into the same unit so we can kind of use them together. And again, it doesn't really matter which one you choose. You can take the feet into miles or you can take the miles into feet here. Miles into feet might be the easier move. So that is what I'm going to do. I'm going to start with my 125 miles and I'm going to convert it into feet using my equality here. And again, we want to go opposites. So miles are on top. So 1 mile on the bottom and 5,280 feet there up on top. Miles cancel gives us something like 660,000 feet. Definitely got your steps in for that day. So that is 660,000 feet we need to go. We now have it in feet. Our conversion factor is in feet per minute. So that's what's going to allow us to get from really distance into time, which is what we're looking for. So we're going to take that number. I'm just going to kind of bring it down here. And we're going to, again, just take the same approach. I can see feet are up on top and I want to get rid of feet. So I do need my conversion factor here where feet is in the opposite location on the bottom. That would be 55 feet per minute. If I stop the calculation right at this point, I am in units of minutes, right? Which is close to what I want, but I do want days. So I do have a couple more conversions that I need to do. I can clearly see minutes are on top. So I want to put minutes on the bottom. So perhaps I go a 60 minutes is 1 hour. Again, minutes cancel. Now I can clearly see I'm in units of hours and they're up on top, which is not what I want. I want days. So I need to get rid of the hours by using my conversion between hours and days, which by the way is 24 and not 60, right? So that's a common one. We're gonna go 24 hours over 1 day here. Hours will cancel. The only unit left is the guy on top, which is what we're looking for. So again, here I would take my 660,000. Basically everything on top is 1, so you don't really need to multiply it by 1, but you can if you like. Gonna hit equals, gonna divide it by 55 here. I got multiple numbers on the bottom. Divide it by 55, I'm gonna hit equals. I'm gonna then divide it by the next number, which is 60, and hit equals. Gonna divide it by the last number, which is 24, and hit equals. And that is going to give me on my calculator the correct answer of 8.3333, a lot of threes, days here. So again here, I wouldn't try to punch it all in at once. I would multiply the top, divide by the first number, hit equals, divide by the next number, hit equals, divide by the last number, hit equals. Significant figure wise, we should end up with how many in this case? I would go with perhaps 2 based off of that one, which is a conversion factor that we have in the problem. 2 significant figures. This guy actually has 3 significant figures. That means we should end up right about there in this case, the way that is written here. Yours on your paper says 55 feet like that, yeah? Or does it say 55.0? It does say, okay. So on yours, it would be correct 3. If it did say 55.0, then it would be 8.33. I thought maybe I changed it on your handout. So 8.33 based on your handout that said 55.0, because at 55.0, it would be 3 significant figures for everybody. The way I have it up here, it's only 2 significant figures in that case. Any questions on that?